Picture this, a place where stars are torn apart by forces so powerful they defy imagination, where temperatures swing from millions of degrees to near absolute zero in the blink of a cosmic eye. Where gravity bends reality itself, and entire worlds are forged in firestorms hotter than the core of our sun. This isn't science fiction, it's the universe as it really exists, and we're about to take you on a journey through its most extreme corners. From black holes that devour light to planets where it rains molten metal, the cosmos is packed with environments so bizarre, they'll make you question everything you thought you knew about reality. Over the next 50 mind-blowing facts, we'll uncover the universe's wildest, most violent, and most mysterious places, each one pushing the limits of physics and human understanding. So buckle up, by the time we're done, you'll never look at the night sky the same way again. Now let's turn up the heat literally. The hottest place in the known universe isn't some fiery star or a volcanic planet. It's the heart of the Phoenix Cluster, a galaxy cluster so scorching that its core reaches temperatures of millions of degrees. To put that in perspective, that's hundreds of times hotter than the surface of our sun. What makes this place an inferno? Two cosmic powerhouses teaming up, a supermassive black hole and a frenzy of star formation. The black hole at the center pumps out energy like a cosmic furnace, while newborn stars ignite in such numbers that they flood the area with blistering radiation. It's a non-stop celestial sauna where gas is heated to extremes we can barely fathom. And here's the wild part, this heat isn't just a local phenomenon. It shapes the entire cluster, influencing how galaxies evolve and even how the universe's largest structures grow. So next time you think a summer day is unbearable, remember, out there things get way hotter. Now let's flip the script from extreme heat to bone-chilling cold. The coldest known object in the universe isn't some distant ice planet. It's the Boomerang Nebula, a cosmic freezer where temperatures plummet to just 1 degree above absolute zero. That's colder than the void of space itself. How does this happen? The nebula's secret lies in its rapid expansion. Imagine a cosmic balloon inflating at breakneck speed, stretching its gas so thin that heat gets sucked right out of it. This expansion chills the nebula to temperatures we can't even replicate in labs on Earth. At its heart, an aging star pumps out material at speeds reaching 164,000 kilometers per hour, creating this frigid environment. Even the cosmic microwave background, the faint afterglow of the Big Bang, is warmer than this icy ghost of a nebula. So while the Phoenix Cluster burns at millions of degrees, the Boomerang Nebula reminds us that the universe has a freezer aisle too, and it's the most extreme one imaginable. Now let's turn our attention from the icy depths of the Boomerang Nebula to a place where the universe unleashes its raw, destructive power. If you thought extreme cold was unsettling, wait until you step into the heart of a supernova remnant like Cassiopeia A, the most radioactive environment known to science. This cosmic graveyard is a swirling storm of lethal radiation, where the aftermath of a star's violent death creates conditions so harsh they defy imagination. When a massive star explodes as a supernova, it doesn't just vanish. It leaves behind a radioactive wreckage that can outshine entire galaxies. Cassiopeia A, the remnant of a star that blew apart around 300 years ago, is still pumping out enough radiation to sterilize any known form of life within light years. The explosion hurls atomic nuclei at nearly the speed of light, creating shockwaves that heat surrounding gas to millions of degrees. This process generates X-rays and gamma rays so intense they can penetrate almost any material, making it one of the deadliest places in the cosmos. But the destruction doesn't stop there. The radiation from supernova remnants like Cassiopeia A plays a crucial role in shaping the universe. It ionizes nearby gas clouds, triggering the birth of new stars, while also seeding space with heavy elements like gold, platinum, and uranium, the very atoms that make up our planet and even our bodies. So while this environment is lethal up close, its aftermath is part of the reason we exist at all. From death comes creation, and Cassiopeia A is a blazing reminder of the universe's endless cycle of destruction and rebirth. Just when you thought the universe couldn't get any more extreme, let's talk about something that bends the very rules of physics: magnetars. These aren't your average neutron stars. Imagine a magnetic field so powerful it could strip the information off every credit card on Earth from halfway across the galaxy. That's the mind-bending reality of magnetars, where magnetic forces reach levels a quadrillion times stronger than anything our planet experiences. At their core, magnetars are the remnants of massive stars that went supernova, but unlike ordinary neutron stars, they are turbocharged with unimaginable magnetic energy. These fields are so intense they twist atoms into elongated needles, warping the very fabric of space around them. If a magnetar were to drift within a few 100,000 miles of Earth, its magnetic pull would liquefy our bodies from the inside out. Not exactly a pleasant thought. But here's where it gets even wilder. Magnetars don't just sit quietly in space. They unleash sudden, violent eruptions called starquakes, where their crusts crack under magnetic pressure, releasing bursts of gamma rays and X-rays. One such blast in 2004 from a magnetar 50,000 light-years away actually disturbed Earth's upper atmosphere despite being halfway across the Milky Way. And if you're wondering how these cosmic monsters form, it all comes down to chaos. When a massive star collapses, its magnetic field gets compressed and amplified to insane levels, turning it into a magnetar. These objects are rare, with only around 30 confirmed in our galaxy, but their impact is anything but small. They remind us that the universe isn't just vast, it's packed with forces so extreme they defy everything we know. So next time you swipe a credit card, just remember somewhere out there, a magnetar could erase it in an instant. Talk about putting everyday problems into perspective. Now let's shift our focus from the crushing grip of magnetars to something equally mind-blowing: neutron stars, the universe's ultimate density champions. Picture this: a single teaspoon of material from a neutron star would weigh billions of tons on Earth. That's like squeezing Mount Everest into a sugar cube. So how does something so unimaginably dense even exist? It all starts with the death of a massive star. When a star at least 8 times heavier than our Sun runs out of fuel, it doesn't go quietly. It explodes in a supernova, blasting away its outer layers and leaving behind an incredibly compact core. Under the force of gravity, protons and electrons are crushed together so violently they merge into neutrons, hence the name. The result, a city-sized object packing more mass than our entire Sun. To put that density into perspective, imagine taking every car on Earth and compressing them into a single thimble. That's still nothing compared to a neutron star. Their gravity is so intense that if you dropped a marshmallow onto one from just a few feet above, it would hit the surface with the energy of a nuclear bomb. But here's where it gets even wilder. Inside a neutron star, matter doesn't behave like anything we know. The core is a bizarre soup of superfluid neutrons, possibly even stranger states like quark-gluon plasma. Some theories suggest the pressure is so extreme that atoms themselves collapse, forming a crystalline crust floating atop this cosmic oddity. And don't forget their spin. Many neutron stars rotate hundreds of times per second, flashing beams of radiation like cosmic lighthouses. We call these pulsars. Others, as we've seen, become magnetars with magnetic fields that rewrite physics. Neutron stars are proof that the universe loves extremes. They're not just dead stars, they're laboratories for the most extreme conditions imaginable, pushing the limits of what matter can endure. So next time you stir sugar into your coffee, remember, out there, a teaspoon could hold the weight of worlds. Now, let's step back from the mind-bending density of neutron stars and look at the universe on an entirely different scale. One so vast it redefines our understanding of space itself. Meet the Hercules-Corona Borealis Great Wall, the largest known structure in the cosmos. This colossal filament of galaxies stretches an astonishing 10 billion light-years across, a number so big it's almost impossible to wrap your head around. To put that in perspective, if you could travel at the speed of light, it would take you 10 billion years to go from one end to the other. That's more than half the age of the universe. What makes this structure so extraordinary isn't just its size, it's the fact that it shouldn't exist. According to our current understanding of cosmology, the universe should be relatively uniform on the largest scales, with matter spread out evenly. But the Hercules-Corona Borealis Great Wall defies that idea. It's a sprawling, interconnected web of galaxy clusters and superclusters, bound together by gravity in a way that challenges the very principles we use to explain the cosmos. Imagine the universe as a cosmic quilt. The standard model predicts a smooth, even pattern, but this structure is like a massive, unexpected stitch running across the fabric. Scientists first spotted it by mapping gamma-ray bursts, the brightest explosions in the universe, which act like signposts marking where galaxies cluster together. When they pieced the data together, they realized these bursts weren't randomly scattered, they traced the outline of something monumental. The existence of such a structure forces us to rethink fundamental questions. How did something this immense form so early in the universe's history? Could there be even larger structures waiting to be discovered? And what does this mean for our theories about dark matter and dark energy, the invisible forces shaping the cosmos? One thing's for sure, the Hercules-Corona Borealis Great Wall is a humbling reminder of how much we still don't know. It's a cosmic mystery written across the sky, daring us to look deeper and question everything we thought we understood about the universe's grand design. Now, let's shift our focus from the vastness of cosmic structures to something spinning at unimaginable speeds. Meet Pulsar J 1748-2446 AD, the fastest spinning pulsar we've ever discovered. This cosmic powerhouse whirls around more than 700 times every single second. To put that in perspective, if you could stand on its surface, you'd be moving at nearly a quarter of the speed of light. Pulsars are the remnants of massive stars that exploded in supernovas, leaving behind incredibly dense neutron stars. What makes them special is their rotation. They spin so fast that their magnetic fields whip up beams of radiation, like a lighthouse flashing across the cosmos. These beams sweep past Earth at precise intervals, making pulsars some of the most accurate natural clocks in the universe. In fact, they're so reliable that scientists have used them to test Einstein's theory of relativity and even navigate spacecraft. But how does something spin this fast without tearing itself apart? The answer lies in its mind-bending density. A pulsar packs more mass than our sun into a sphere no bigger than a city. That intense gravity holds it together even as it whips around at dizzying speeds. And here's the wild part, some pulsars slow down over time, but others, like Pulsar J 1748-2446 AD, defy expectations by maintaining their blistering pace. These spinning wonders aren't just cosmic curiosities, they're laboratories for extreme physics. Their beams carry clues about the nature of matter under conditions we could never recreate on Earth. And as we listen to their rhythmic pulses, we're reminded that the universe is full of phenomena that push the limits of what we thought was possible. Now let's take a breath, because where we're headed next, the air itself is anything but calm. Imagine winds so fierce they could circle Earth's equator in just 5 hours. That's the reality on HD 189733b. A planet where winds rage at an astonishing 5,400 miles per hour. To put that into perspective, the strongest hurricanes on Earth top out at around 200 miles per hour. The winds on this distant world are more than 20 times faster, turning its atmosphere into a relentless supersonic blender. What fuels such extreme weather? HD 189,733b orbits dangerously close to its host star, completing a full revolution in just 2.2 Earth days. This proximity creates a temperature difference of thousands of degrees between the planet's scorching day side and its slightly cooler night side. That extreme thermal contrast drives winds that scream across the planet at speeds rivaling some spacecraft. And here's the twist: these winds aren't just fast. They're loaded with microscopic particles of silicate, essentially raining molten glass sideways. Scientists study planets like HD 189,733b to understand how atmospheres behave under conditions we'd never see in our solar system. Its winds are so powerful they redistribute heat across the entire planet, erasing any hope of a temperate zone. While Earth's weather systems are shaped by oceans and land masses, this world's atmosphere operates on a scale that defies earthly logic. It's a reminder that when it comes to extreme environments, the universe doesn't just push boundaries, it obliterates them. From winds that could shred a planet to a world where the ground itself is constantly erupting, let's turn our attention to Io, Jupiter's most volatile moon. This isn't just a place with the occasional volcano. Io is the most geologically active body in the entire solar system, with hundreds of erupting volcanoes at any given moment. Imagine a landscape where lava lakes bubble like cauldrons and plumes of sulfur shoot hundreds of miles into space. That's everyday life on Io. What makes this tiny moon so explosive? The answer lies in Jupiter's immense gravity. Io orbits so close to the gas giant that the planet's gravitational pull stretches and squeezes the moon's interior like putty. This constant flexing generates enormous tidal forces, creating friction that heats Io's core to extreme temperatures. That heat has to go somewhere, so it blasts through the surface in the form of relentless volcanic eruptions. Some of these eruptions are so powerful they've been spotted by telescopes on Earth, spewing material high above Io's thin atmosphere. But here's what's truly wild: Io's volcanoes don't just spew lava like Earth's. They often erupt with sulfur and sulfur dioxide, painting the moon's surface in vivid yellows, oranges, and reds. The largest lava lakes, like Loki Patera, are wider than entire cities and churn with molten rock that could swallow skyscrapers. And because Io has almost no atmosphere to slow them down, volcanic plumes can shoot debris into orbit, some even escaping into space. Scientists study Io to understand not just extreme volcanism, but how tidal forces shape worlds across the universe. It's a reminder that even a small moon caught in the gravitational tug of war of a giant planet can become one of the most violent places imaginable. Next time you look up at Jupiter, remember, hidden in its shadow is a world where the ground never stops shaking. Now, let's shift our gaze from the fiery chaos of Io to a world that redefines the word hostile, Venus. Often called Earth's twin because of its similar size, Venus couldn't be more different in reality. This is a planet where the surface temperatures soar to nearly 900 degrees Fahrenheit, hot enough to melt lead. The air is so thick with pressure that it feels like being submerged under 3,000 feet of ocean. And if that weren't enough, the skies rain sulfuric acid, turning the entire planet into a nightmare of corrosive storms. What turned Venus into such a hellscape? The answer lies in a runaway greenhouse effect. Unlike Earth, where greenhouse gases are balanced, Venus's atmosphere is almost entirely carbon dioxide, trapping heat with terrifying efficiency. Billions of years ago, sunlight baked the planet's surface, evaporating any oceans it might have had. Water vapor, a potent greenhouse gas, flooded the atmosphere, trapping even more heat. Temperatures skyrocketed, carbonates in the rocks baked away, releasing even more carbon dioxide into the air. It's a vicious cycle that turned Venus into the solar system's ultimate pressure cooker. But the horror doesn't stop there. Venus's thick clouds of sulfuric acid reflect most sunlight, making the surface eerily dim despite the blistering heat. Winds high in the atmosphere whip around the planet at hurricane speeds, yet at ground level the air is stagnant, heavy with the weight of the crushing atmosphere. Even spacecraft sent to explore Venus don't last long. The Soviet Venera probes, some of the only missions to survive landing, melted or were crushed within hours. Yet, studying Venus isn't just about marveling at its extremes. It's a stark warning of what happens when a greenhouse effect spirals out of control. Some scientists even see Venus as a glimpse into Earth's possible future if climate change goes unchecked. So while it may be the most hostile planet in our solar system, Venus also holds critical lessons about the fragility of habitable worlds and the fine line between paradise and inferno. Now let's journey from the crushing hellscape of Venus to the mind-bending forces lurking near black holes where gravity doesn't just pull, it stretches. Imagine being caught in the grip of a black hole's tidal forces, a process so violent it has a name straight out of a horror story: spaghettification. Here's how it works. A black hole's gravity is so intense that the pull on one side of an object, say, a star or even an unlucky astronaut, is vastly stronger than the pull on the other side. This difference in force stretches the object into a long, thin strand like cosmic taffy. The technical term is tidal disruption, but spaghettification captures the sheer terror of it. Picture a star wandering too close to a supermassive black hole. The side nearest the black hole gets yanked inward faster than the far side, tearing the star apart in a spectacular display of cosmic destruction. But what would it feel like to experience this firsthand? If you were falling feet first toward a black hole, the gravity at your feet would be exponentially stronger than at your head. You'd stretch thinner and thinner until you were nothing more than a stream of atoms spiraling into the abyss. The good news, you'd likely lose consciousness long before the worst of it, thanks to the extreme tidal forces scrambling your nervous system. This isn't just theoretical. Astronomers have observed stars being spaghettified, their remnants glowing brightly as they're devoured, a phenomenon called a tidal disruption event. These violent encounters release bursts of energy that can outshine entire galaxies for months. So while black holes might be invisible, their extreme tides leave behind unmistakable fingerprints. What makes this even wilder? The size of the black hole changes the experience. Smaller black holes have steeper gravitational gradients, meaning spaghettification happens much closer to the event horizon and far more violently. With supermassive black holes, you might cross the event horizon before noticing the stretch, but once inside, there's no coming back. It's a one-way trip into the universe's most extreme shredder. From crushing pressures to stellar spaghetti, the cosmos never fails to remind us. Out there, the laws of physics can turn into a nightmare. And speaking of nightmares, wait until you hear about the next extreme, where light itself bends to the will of the universe's brightest monsters. Now, let's shift our gaze from the darkness of black holes to the blinding brilliance of quasars, cosmic beacons so intense they outshine entire galaxies. These aren't just bright objects, they're the universe's ultimate light shows, powered by supermassive black holes with appetites that defy imagination. At the heart of every quasar lies a black hole millions to billions of times more massive than our Sun. But unlike the silent voids we've explored, these monsters are anything but quiet. As matter spirals toward the black hole, it doesn't just vanish. It forms a swirling disk of superheated gas and dust, glowing white-hot under unimaginable friction. This accretion disk radiates energy across the electromagnetic spectrum, from radio waves to X-rays, making quasars visible across billions of light years. What's truly staggering is the scale of their luminosity. A single quasar can emit thousands of times more light than the Milky Way, all from a region no larger than our solar system. That's like cramming the output of every star in our galaxy into a space smaller than Pluto's orbit. The energy released is so immense that quasars can outshine their host galaxies, appearing as pinpricks of light in telescopes despite their cosmic significance. But quasars aren't just celestial vanity projects, they play a crucial role in shaping the universe. The jets of plasma they eject at near light speed can stretch for millions of light years, carving out bubbles in intergalactic space and influencing star formation in distant galaxies. These jets act like cosmic blowtorches, heating surrounding gas and preventing it from collapsing into new stars, effectively putting a cap on galactic growth. Interestingly, quasars were more common in the early universe, a clue that they might be linked to galaxy formation itself. As galaxies matured, their central black holes either ran out of fuel or became too efficient, switching off the quasar's dazzling display. Today, we see them as relics of a more violent cosmic era, their light serving as time capsules from when the universe was young and chaotic. So while black holes stretch and shred, quasars illuminate and transform. They're proof that even in the darkest corners of space, light can take on forms beyond our wildest dreams. And if you think that's extreme, just wait until we explore the voids where light dares not go. But if quasars are the universe's brightest beacons, then cosmic voids are its most baffling shadows. Picture this, vast stretches of space so empty they make the blackness between stars seem crowded. The Boötes Void, one of the largest known, spans 330 million light-years yet contains fewer than 60 galaxies. To put that in perspective, our local neighborhood would pack thousands of galaxies into the same space. These voids aren't just gaps, they're cosmic anomalies that defy expectations. According to our best models, matter should be distributed somewhat evenly after the Big Bang, like froth in a bubble bath. But the Boötes Void suggests some bubbles popped entirely, leaving behind deserts of near-nothingness. The handful of galaxies trapped inside move strangely too, as if fleeing the emptiness itself, a phenomenon astronomers call void drift. What creates such extreme darkness? One theory points to ancient sound waves from the early universe, where regions of low density stretched into voids as space expanded. Another suggests smaller voids merged over billions of years, like puddles drying up to form a lake of absence. Either way, these voids force us to rethink how structure forms in the cosmos. They're not just empty space, they're active players, their gravity subtly tugging at the universe's web of galaxies. And here's the twist, voids might hold clues to dark energy. Their expansion rates don't quite match predictions, hinting that something invisible is stretching space faster in these regions. So while they appear barren, these cosmic deserts could be hiding the universe's deepest secrets. From blinding quasars to abyssal voids, space never runs out of extremes, and our next stop is where even atoms get crushed beyond recognition. Now let's journey to a place where pressure bends the very rules of physics, the heart of a neutron star. Imagine taking the entire mass of our sun and squeezing it into a sphere no wider than a city. The result, a cosmic pressure cooker so intense that atoms themselves collapse. At the core, gravity wins the ultimate tug of war, crushing protons and electrons together until they merge into neutrons. But even that's just the beginning. Here, matter doesn't just get dense, it transforms into states so exotic they defy earthly logic. Scientists call it quantum chromodynamics in action, where the forces governing particles shift under extreme pressure. Quarks, the building blocks of protons and neutrons, might break free from their usual teams, forming a bizarre soup of ultra-dense matter. Some theories even suggest the core could crystallize into a lattice of pure neutrons or become a superfluid with zero friction, flowing endlessly without losing energy. What creates this crushing environment? Picture the aftermath of a supernova, where a dying star's core implodes with unimaginable force. The outer layers rebound in a spectacular explosion, but the core keeps collapsing until quantum physics pushes back, creating a neutron star. Its interior isn't just layered, it's like an onion forged in a cosmic furnace. The outer crust is a rigid shell of iron nuclei, while deeper layers dissolve into a sea of neutrons. And at the very center, that's where the real mystery lies. Some models predict a core so dense it becomes a quark star, or even a gateway to something stranger. The wildest part, neutron stars are nature's laboratories for extremes we can't replicate on Earth. By studying them, we catch glimpses of how matter behaves when the universe turns the pressure up to trillions of times what our planet experiences. From voids of nothingness to stars where even atoms surrender, the cosmos keeps rewriting the rules, and our next stop is where gravity becomes the ultimate cosmic tyrant. Now let's step into the realm where gravity becomes an unstoppable force: black holes. These cosmic monsters warp space and time so severely that nothing, not even light, can break free once it crosses the point of no return. That boundary is called the event horizon, and it's the ultimate one-way door in the universe. Picture it like a waterfall's edge. Once you go over, there's no climbing back. At the heart of a black hole lies the singularity, a point where all the stars' crushed mass collapses into infinite density. Here, the laws of physics as we know them break down completely. If you've seen the movie Interstellar, Gargantua gave us a stunning visual of how a black hole distorts light around it, creating a glowing ring of doomed matter spiraling inward. That's not just Hollywood magic, it's based on real science. The gravitational pull is so intense that it stretches nearby objects into spaghetti-like strands, a process fittingly called spaghettification. But how does something this extreme form? Imagine a massive star many times heavier than our Sun, running out of fuel. Without the outward push of nuclear fusion, its core implodes under its own weight. If the core is massive enough, no force can stop the collapse and a black hole is born. Some are small, just a few miles wide, while supermassive ones, like the one at the center of our galaxy, weigh as much as millions or even billions of suns. What's truly mind-bending is how black holes warp reality itself. Time slows to a crawl near the event horizon. A minute for you could be years for someone far away. And if you could survive the trip inside, the singularity would be a place of infinite curvature, where space and time cease to behave normally. Scientists are still unraveling these mysteries, but one thing's certain: black holes are the universe's most ruthless gravitational prisons. Next, we'll witness a storm so vast it could swallow planets whole, a tempest that's raged for centuries and shows no sign of fading. Now, let's turn our attention to a storm of unimaginable scale, one that makes Earth's hurricanes look like gentle breezes. Jupiter's Great Red Spot is a colossal tempest wider than our entire planet, and it's been churning for at least 400 years. Imagine a hurricane so vast it could swallow Earth whole, yet instead of fading in days or weeks, it's raged for centuries. This isn't just a storm, it's a permanent fixture in Jupiter's turbulent atmosphere. What keeps this monster alive, unlike storms on Earth, which lose energy when they hit land or cool waters, Jupiter's Great Red Spot has no surface to disrupt it. The planet is a giant ball of gas, so the storm feeds off the endless currents beneath it, spinning like a top in a fluid with no friction to slow it down. And because Jupiter's atmosphere is packed with swirling jet streams, these winds act like fuel, constantly feeding the storm's fury. To put it in perspective, the fastest winds inside the Great Red Spot scream at over 400 miles per hour, more than twice the speed of Earth's strongest hurricanes. But here's the twist: while our storms are driven by warm ocean water, Jupiter's storm is powered by the planet's own internal heat, left over from its formation billions of years ago. Time-lapse images from spacecraft like Juno reveal the storm's hypnotic dance, a swirling mass of crimson clouds, twisting and shifting but never dissipating. Scientists still debate why it's red, with theories ranging from chemical reactions in the atmosphere to sunlight breaking down molecules in the clouds. One thing's certain: this storm is a testament to the raw, untamed power of nature on a scale we can barely comprehend. Next, we'll explore worlds where seasons aren't just extreme, they're downright apocalyptic. Now picture a world where seasons aren't just a change in weather, they're full-blown planetary disasters. Some exoplanets take extreme seasons to a whole new level, with axial tilts so severe that their climates swing between scorching infernos and frozen wastelands. Unlike Earth's relatively gentle 23-degree tilt, these planets can lean at angles of 90 degrees or more, turning their poles into temporary tropics and their equators into icy deserts. Take Kepler 432b, for example. This distant world orbits its star at such a dramatic angle that one pole bakes under constant sunlight for half the year, while the other plunges into endless night. When the seasons finally shift, the planet doesn't just warm or cool, it flips entirely. The once sunlit pole freezes over, and the dark side erupts into a furnace, creating storms and temperature swings that would make Earth's harshest weather seem tame. Scientists use advanced climate models to simulate these chaotic environments, revealing how jet streams fracture and reform, dragging hurricanes and blizzards across the planet's surface. On some of these worlds, lakes of molten lava might boil away under the summer sun, only for the same regions to be buried under miles of ice when winter returns. What causes such extreme tilts? Many of these planets were likely knocked sideways by collisions with other celestial bodies early in their history, or they might be locked in gravitational battles with neighboring giants that yank their axes back and forth over time. The result is a climate that doesn't just change, it erupts, collapses, and reinvents itself with every orbit. Next, we'll venture into the realm of planets with orbits so wild they defy all expectations. Now, let's take a wild ride through the cosmos to explore planets that don't just orbit their stars, they practically slingshot around them. Meet HD 80606b, a planet with an orbit so stretched and eccentric, it makes Pluto's path look like a perfect circle. While most planets follow nearly circular orbits, this extreme world swings so close to its star that it briefly becomes a scorching inferno, then catapults out to distances where even sunlight struggles to reach. Imagine a year on HD 80606b. For a few fiery days, it's closer to its star than Mercury is to the Sun, roasting at temperatures hot enough to melt steel. Then, as it hurtles away, its atmosphere freezes into a deep chill, creating temperature swings of over 1,000 degrees in just hours. These violent shifts don't just make the weather unpredictable, they tear at the planet's very structure, triggering storms that could engulf entire continents if it had any. What causes such a chaotic orbit? Often, it's the gravitational tug of war with other massive planets or passing stars that yanks these worlds into their extreme path. Some might have been born in the turbulent outskirts of their solar systems, only to be flung inward by cosmic collisions. Others could be survivors of systems that lost planets in violent rearrangements, leaving them as lone travelers on these wild elliptical journeys. For life, these orbits are a death sentence. The constant extreme heating and cooling would vaporize any liquid water and shred organic molecules. Even the hardiest microbes would struggle to survive such relentless chaos. Yet, studying these planets helps astronomers understand how solar systems evolve and how rare, stable, life-friendly orbits like Earth's truly are. Next, we'll step into the eerie realm of worlds where one side is forever day and the other is locked in eternal night. Now picture a world where the sun never sets on one side and never rises on the other. These are tidally locked planets, cosmic oddities where one hemisphere is forever bathed in daylight while the other drowns in endless night. The reason: gravity. Just as our moon always shows Earth the same face, these planets are locked in a gravitational embrace with their stars, rotating just once per orbit. The result is a planet split into two extreme realms, a scorching, sun-blasted side and a frozen, lightless wasteland. On the day side, temperatures can soar high enough to melt rock, creating vast deserts where any atmosphere would be superheated into a swirling maelstrom. Meanwhile, the night side plunges into such deep cold that gases like nitrogen or carbon dioxide could freeze solid, forming icy plains beneath a starless sky. But the most fascinating part lies in between the twilight zone, a narrow band where perpetual sunset conditions might offer just enough warmth for liquid water and perhaps the faintest whisper of habitability. The atmosphere on these worlds doesn't stay still. Hot air from the day side rushes toward the cold night, generating hurricane-force winds that never cease. Some tidally locked planets might even have rivers of molten metal flowing on their day side, while their night side could harbor glaciers of frozen air. It's a constant battle between fire and ice, with the planet's own weather acting as a desperate referee. Could life exist in such extremes? It's unlikely on the surface, but beneath icy crusts or in deep caves, organisms might huddle near geothermal vents, clinging to warmth in the eternal dark. For astronomers, these planets are laboratories for understanding how atmospheres behave under relentless stress, and a reminder that Earth's gentle cycle of day and night is a rare cosmic gift. Next, we'll witness the universe's most dazzling light show auroras so powerful they could engulf entire planets. Now, let's turn our gaze to a spectacle that makes Earth's northern lights look like a faint glow, Jupiter's auroras. These aren't just shimmering curtains of light, they're colossal, energetic displays that could swallow our entire planet, the secret behind their intensity. Jupiter's monstrous magnetic field, the strongest in the solar system, and its fiery moon Io, which pumps the gas giant's atmosphere with charged particles. Unlike Earth's auroras, which are sparked by solar wind, Jupiter's lights are fueled by its own cosmic engine. Io's hundreds of active volcanoes spew sulfur and oxygen into space, where Jupiter's magnetic field grabs them and accelerates the particles to near light speeds. When these particles slam into Jupiter's poles, they unleash auroras so bright they outshine the sunlit side of the planet. The scale is mind-bending. While Earth's auroras might stretch a few hundred miles, Jupiter's can span tens of thousands, large enough to envelop multiple Earths. And they're not just bigger, they're hundreds of times more energetic, glowing in X-rays and ultraviolet light invisible to our eyes. Hubble's images reveal these auroras as swirling, electric blue rings, pulsing with enough power to light up civilizations. But here's the twist: Jupiter's auroras never stop. On Earth, the northern lights fade when solar activity wanes. On Jupiter, the show is eternal, thanks to Io's relentless volcanic tantrums. It's a reminder that even in the realm of extreme beauty, the universe has tiers, and Jupiter sits firmly at the top. Next, we'll encounter particles racing across the cosmos with the energy of a speeding baseball, ultra-high-energy cosmic rays. Now, let's step into the realm of particles so powerful they defy imagination, ultra-high-energy cosmic rays. These aren't your average subatomic particles. Imagine a single particle hurtling through space with the energy of a baseball thrown at full speed. That's the staggering force packed into these cosmic bullets, and scientists still aren't entirely sure where they come from. Most cosmic rays are protons or atomic nuclei, but the ultra-high-energy ones are rare and baffling. They travel at nearly the speed of light, carrying millions of times more energy than particles in human-made accelerators. When one of these strikes Earth's atmosphere, it creates a shower of secondary particles so vast it can spread over miles. Detectors like the Pierre Auger Observatory in Argentina catch these cascades, helping us piece together their origins. The mystery deepens when we ask where they're born. Some might come from supermassive black holes at galaxy centers, where matter is torn apart and ejected at unimaginable speeds. Others could be flung our way by colliding galaxy clusters or even more exotic cosmic events we haven't discovered yet. The twist: the highest energy cosmic rays shouldn't survive their journey across the universe. Intergalactic space is filled with radiation that should sap their energy, yet here they are defying the odds. What's clear is that these particles are messengers from the universe's most violent corners. Every time one arrives, it's like getting a postcard from a cosmic battlefield we can't yet see. And as detectors grow more sensitive, we're inching closer to solving one of astrophysics' greatest puzzles. Next, we'll witness storms so vast they can engulf an entire planet, Mars' global dust tempests. Now, picture a planet where the sky turns into a swirling, rust-colored nightmare for months on end. Mars is home to the most extreme dust storms in the solar system, capable of growing so vast they shroud the entire planet in a thick, choking haze. Unlike Earth's short-lived dust devils, these tempests can rage for half a Martian year, sometimes even longer. The sheer scale is hard to grasp. Imagine a storm so massive it blankets every continent, ocean, and mountain range on Earth at once. That's what happens on Mars. Winds whip dust particles into the atmosphere at speeds of over 60 miles per hour. But here's the twist: because Mars' air is so thin, those winds don't pack the same punch as a hurricane. Instead, it's the dust itself that becomes the real menace, blotting out the sun and turning day into twilight. For explorers, both robotic and human, these storms are a serious challenge. Solar-powered rovers like Opportunity have been forced into hibernation when dust blocked their energy supply, and in some cases the storms proved fatal. Future colonists will need to design habitats with robust power backups and air filtration systems to survive months under this oppressive shroud. Yet there's a strange beauty to these storms. They sculpt Mars' surface, shifting dunes and revealing hidden layers of geology. And while they might complicate our plans to settle the red planet, they also teach us about the dynamic forces shaping worlds beyond our own. Next, we'll dive into an ocean locked beneath miles of ice where the conditions might just be perfect for alien life. But now, let's journey from the dusty storms of Mars to a world encased in ice, where the cold hides a secret that could rewrite our understanding of life in the cosmos. Europa, one of Jupiter's enigmatic moons, is sheathed in an ice shell up to 15 miles thick, making it one of the most extreme icy environments in the solar system. Yet beneath this frozen crust lies something extraordinary, a vast global ocean holding more than twice the water found on Earth. What keeps this ocean from freezing solid? The answer lies in Europa's dance with Jupiter. The moon's orbit isn't perfectly circular, and Jupiter's immense gravity stretches and squeezes Europa like putty. This tidal heating generates enough warmth to melt ice deep below the surface, creating a liquid ocean that could span the entire moon. Imagine an underwater world with no sunlight, where the seafloor might host hydrothermal vents, geysers of superheated water rich in minerals, much like those in Earth's deepest oceans. And that's where things get thrilling. On Earth, such vents teem with life, from tube worms to bacteria thriving in total darkness. Could Europa's hidden ocean harbor similar organisms? Scientists think it's possible. The combination of liquid water, heat, and chemical nutrients makes this icy moon one of the top candidates for finding extraterrestrial life. Future missions like NASA Europa Clipper aim to fly through its plumes, jets of water vapor erupting from cracks in the ice, to search for telltale signs of biology. Europa's ice isn't just a barrier, it's a dynamic, shifting landscape. The surface is crisscrossed with cracks and ridges, evidence of the ocean below pushing and pulling on its frozen ceiling. Some areas even resemble Earth's ice shelves, with chunks that have broken apart and refrozen. This constant churning could transport chemicals from the surface down into the ocean, fueling potential ecosystems in the dark. So while Europa's exterior is colder than Antarctica, its hidden depths might just be the perfect cradle for life, proving that even in the most extreme environments, the universe finds a way. Next, we'll witness the raw power of lightning strikes so intense they dwarf anything on Earth. From the hidden oceans of Europa, we now turn to a spectacle of raw cosmic power. Saturn's superbolts, lightning strikes so intense they make Earth's fiercest storms look like flickering candles. These aren't just ordinary bolts, they're thousands of times more powerful, unleashing energy that could vaporize entire cities in an instant. So how does Saturn brew such monstrous lightning? The secret lies in its churning, turbulent atmosphere. Unlike Earth, where lightning forms in water-rich storm clouds, Saturn's bolts erupt in a cauldron of ammonia, hydrogen, and helium. As these gases collide and swirl, they generate massive electrical charges, building up until they explode in blinding superbolts. Some of these strikes stretch hundreds of miles across, lighting up Saturn's thick cloud decks like a cosmic fireworks show. But here's the eerie part: we can actually hear these strikes. Spacecraft like Cassini have captured radio emissions from Saturn's lightning, translating them into crackling, otherworldly static. These recordings reveal storms that rage for months, some so vast they could swallow Earth whole. Imagine standing on Saturn's surface, though its crushing pressure and winds would flatten you in seconds, and hearing the sky roar with thunder that shakes the ground like an endless earthquake. What makes these superbolts even more fascinating is their role in Saturn's atmosphere. They churn up molecules that create complex organic compounds, hinting at the chaotic chemistry that might have shaped the early solar system. And while we'll never see these bolts with our own eyes, Saturn's thick clouds hide them from view. Their radio whispers tell us a story of a planet where nature's fury operates on an unimaginable scale. Next, we'll venture to a world scarred by one of the most colossal impacts in the solar system, a crater so vast it rewrote the history of Mars. Now, let's journey to a scarred landscape that tells a violent tale from Mars' ancient past, Utopia Planitia, a crater so colossal it dwarfs anything Earth has ever seen. Stretching over 2,000 miles wide, this impact basin is one of the largest in the entire solar system, a silent witness to a cataclysm that reshaped the red planet. The asteroid that carved out Utopia Planitia wasn't just big, it was a planet wrecker. Imagine a rock the size of a small moon slamming into Mars with enough force to send shockwaves rippling across its surface. The impact would have vaporized rock, flung debris into space, and triggered volcanic eruptions that lasted for millennia. The energy released would have been equivalent to millions of nuclear bombs detonating at once, leaving a wound so deep it altered Mars' geology forever. What makes Utopia Planitia especially fascinating is what lies beneath its dusty surface. Orbiting spacecraft have detected vast deposits of water ice, hidden just a few feet underground. This discovery suggests the basin might have once been an ancient ocean, frozen in time after Mars lost its atmosphere. The crater's flat, smooth floor, a stark contrast to the rugged highlands around it, hints at sediments deposited by long-vanished water, making it a prime target in the search for signs of past life. But Utopia Planitia isn't just a relic of destruction, it's also a beacon for the future. NASA Viking 2 lander touched down here in the 1970s, and more recently, China's Zhurong rover explored its terrain, uncovering clues about Mars' climate history. Every rock and ripple in this vast basin tells a story, from the chaos of its birth to the quiet, frozen world it is today. Next, we'll dive into a world where geysers blast water into the void, a moon where the universe itself seems to be crying out for attention. Now, let's turn our gaze to a tiny moon with a big secret, Enceladus, where geysers of ice and water erupt into the darkness of space like cosmic fireworks. This frozen world, barely 300 miles wide, hides one of the most astonishing features in our solar system: cryovulcanos that blast towering plumes hundreds of miles above its surface. What makes these geysers so extraordinary isn't just their height, it's what they're made of. Instead of lava, Enceladus spews water vapor, ice particles, and even organic molecules, a cocktail that hints at something remarkable beneath its icy crust. The Cassini spacecraft, which studied Saturn and its moons for over a decade, flew through these plumes and detected salts and silica, telltale signs of a subsurface ocean churning below. Scientists believe this hidden ocean is kept liquid by tidal forces. Saturn's gravity stretches and squeezes Enceladus, generating enough heat to melt ice deep underground. The geysers act like escape valves, shooting material from this ocean into space where Cassini could sample it. The presence of organic compounds, along with the energy from hydrothermal vents on the ocean floor, makes Enceladus one of the top candidates in the search for extraterrestrial life. But the plumes aren't just a scientific curiosity, they're also reshaping Saturn itself. The ice particles from Enceladus feed Saturn's faint E-ring, a shimmering band of dust that glows in the sunlight. Every eruption adds to this ring, a cosmic recycling program millions of years in the making. From a distance, Enceladus might look like just another frozen speck, but its geysers tell a story of hidden oceans, tidal forces, and maybe, just maybe, the building blocks of life. Next, we'll venture into a realm of invisible danger where radiation belts wield enough power to fry even the hardiest spacecraft. Now, let's journey into a different kind of extreme, one that's invisible but deadly. Jupiter, the solar system's largest planet, doesn't just boast a mighty magnetic field, it wields it like a cosmic weapon. Surrounding the gas giant are radiation belts so intense they could fry unprotected electronics in seconds. These belts are like invisible prisons for charged particles trapped by Jupiter's magnetic field, which is 20,000 times stronger than Earth's. Electrons and ions whip around at nearly the speed of light, creating a swirling storm of radiation. The most dangerous zone, known as the inner radiation belt, packs enough punch to deliver a lethal dose to any unshielded spacecraft or astronaut venturing too close. What makes Jupiter's radiation so extreme? It's a combination of the planet's rapid rotation spinning once every 10 hours and its volcanic moon, Io. Io's eruptions spew sulfur and oxygen into space, where Jupiter's magnetic field ionizes them, supercharging the belts. This creates a donut-shaped ring of radiation so harsh that even NASA, a heavily armored Juno spacecraft, had to take precautions, using a titanium vault to protect its instruments. But the belts aren't just a hazard, they're also a natural particle accelerator, helping scientists study high-energy physics in ways impossible on Earth. And they produce something eerie radio emissions picked up by antennas as ghostly whistles and static. Jupiter's radiation belts are a reminder that in space, danger doesn't always come with a flashy explosion. Sometimes it's an invisible force lurking just beyond sight. Next, we'll witness a collision of cosmic titans, where entire galaxies crash in a spectacle of dark matter and fire. Now, let's turn our attention to one of the most violent and revealing events in the cosmos, the collision of entire galaxy clusters. The Bullet Cluster, located about 3.7 billion light-years away, is the aftermath of two massive clusters smashing into each other at unimaginable speeds. This cosmic wreckage isn't just a spectacle, it's a smoking gun for dark matter. When these clusters collided, their galaxies passed right through one another, but their hot gas clouds filled with normal matter slammed together, heating up and glowing in X-rays. Meanwhile, something invisible kept moving ahead, undisturbed. That something was dark matter. By mapping the gravitational lensing effects where the cluster's mass bends light from distant galaxies, scientists saw that most of the mass wasn't where the gas was. It was where the galaxies were, proving dark matter doesn't interact with light or normal matter the way we'd expect. This collision was like a cosmic experiment, showing dark matter and normal matter behaving differently under extreme conditions. The Bullet Cluster became the first direct evidence that dark matter isn't just a theory, it's real, and it shapes the universe in ways we're only beginning to understand. But the story doesn't end there. The sheer violence of this event also reveals how galaxy clusters evolve, merging over billions of years to form the largest structures in the universe. Next, we'll dive into another cosmic powerhouse where the Sun itself shows its terrifying fury. Now, imagine a force so powerful it could knock out entire power grids and cripple satellites. Welcome to the fury of solar flares. The most extreme example in recorded history is the Carrington event of 1859. Back then, a massive solar storm sent a surge of charged particles toward Earth, causing telegraph systems, the cutting-edge technology of the day, to spark, catch fire, and even operate without power. Auroras, normally confined to polar regions, lit up skies as far south as Cuba and Hawaii. But what would happen if a flare like that hit us today? Modern mega flares, though rare, pack enough energy to disrupt GPS signals, fry satellite electronics, and induce currents in power lines strong enough to melt transformers. In 1989, a much smaller solar storm left 6 million people in Quebec without electricity for 9 hours. A Carrington-level event today could plunge entire continents into darkness, damage undersea internet cables, and cost trillions in repairs. The sun's eruptions are a reminder that even our own star harbors extremes capable of reshaping civilization. And as we rely more on technology, the stakes only get higher. Next, we'll venture beyond our solar system to worlds where the skies rain molten metal, a spectacle even more bizarre than solar fury. Now, let's journey to a place where the skies defy imagination. Welcome to the bizarre realm of hot Jupiters. These gas giants orbit so close to their stars that their atmospheres reach temperatures hot enough to vaporize metal. Picture a world where the clouds aren't made of water but of iron and silicate particles floating in a scorching haze. On planets like WASP 76b, the dayside temperatures soar above 4,000 degrees Fahrenheit, hot enough to turn metals into gas. But here's where it gets even stranger. As these vaporized metals drift to the cooler night side, they condense into droplets and fall as rain. That's right, on these worlds, it literally rains molten iron. Imagine standing under a storm where the droplets aren't water but liquid metal, sizzling as they hit the ground. The extreme gravity of hot Jupiters keeps their atmospheres from escaping, creating a perpetual cycle of vaporization and precipitation. These planets are so alien that they challenge our understanding of weather itself. And while we can't visit them yet, telescopes have detected the signatures of these metal clouds, giving us a glimpse into their otherworldly climates. Up next, we'll explore the emptiest corners of the cosmos, where matter is so scarce it's almost like stepping into a void. Now, let's step into the vast emptiness between galaxies, where the universe stretches into near nothingness. In these cosmic voids, the density of matter is so low it's almost a perfect vacuum, far emptier than anything we can create on Earth. Picture a space so sparse that a single atom might be the only occupant in a volume the size of your bedroom. These voids aren't just empty gaps, they're dynamic regions where the rules of physics play out on an unimaginable scale. Gravity's weak grip here means matter rarely clumps together, leaving these areas eerily quiet compared to the crowded galaxy clusters nearby. Yet even in this near-perfect vacuum, particles drift at incredible speeds, their motions shaped by the subtle pull of dark matter and the expansion of space itself. What's truly fascinating is how these voids influence the universe's structure. They act like cosmic buffers, pushing galaxies into the dense walls and filaments of the cosmic web. Without these vast, empty regions, the universe wouldn't have the intricate, sponge-like structure we see today. Up next, we'll warp into the realm of extreme time, where gravity bends the very fabric of reality. Now, let's bend the rules of time itself. Imagine standing on a planet orbiting a black hole, where gravity is so intense that time crawls compared to the rest of the universe. This isn't science fiction, it's Einstein's theory of relativity in action. The closer you get to a black hole's immense gravitational pull, the slower time passes for you relative to someone far away. Take Miller's planet from Interstellar as a real-world example. Near the black hole Gargantua, 1 hour on the surface equals 7 years back on Earth. That's time dilation at its most extreme. The planet's proximity to the black hole stretches spacetime so dramatically that aging becomes wildly skewed. While a crew member spends minutes on the surface, decades fly by for those waiting in orbit. This mind-bending effect isn't just a movie plot, it's grounded in real physics. Black holes warp the fabric of the universe so severely that they twist time itself. For astronauts venturing too close, returning to their original timeline would mean finding a world that's aged centuries without them. It's a stark reminder of how gravity doesn't just shape space, it controls the very flow of time. Next, we'll unravel one of the cosmos' strangest mysteries, a motion in the universe that defies all expectations. Now, let's step into the shadows of the cosmos, where an unseen force tugs at entire galaxy clusters like puppets on strings. This eerie phenomenon, known as the dark flow, is one of the universe's most baffling mysteries. Imagine billions of galaxies drifting together in the same direction, as if pulled by something beyond the edges of our observable universe. Scientists first noticed this strange motion while studying the cosmic microwave background, the faint afterglow of the Big Bang. They found that hundreds of galaxy clusters were moving at staggering speeds, millions of miles per hour, toward a single point in space. The kicker: there's nothing visible there to explain it. No supercluster, no massive structure, just emptiness. So what's behind this cosmic tug of war? One wild theory suggests the dark flow could be evidence of other universes beyond our own. Picture a neighboring universe with gravity so strong it's yanking our galaxy clusters across the cosmic void. Another idea points to primordial irregularities in spacetime itself, leftovers from the universe's explosive birth. While the true cause remains unknown, the dark flow challenges everything we thought we knew about the universe's boundaries. It's a haunting reminder that even the vast cosmos we see might just be a speck in something far grander. Up next, we'll meet a star so colossal it makes our sun look like a grain of sand. Now, let's shift our gaze to the giants of the cosmos, stars so enormous they stretch the limits of what we thought possible. Meet UY Scuti, a hypergiant star that makes our sun look like a speck of dust. If you place this colossal star at the center of our solar system, its surface would reach beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, and Mars whole. To put its scale into perspective, UY Scuti's diameter is around 1,700 times larger than the Sun's. That means if the Sun were the size of a marble, UY Scuti would be as wide as a 3-story building. But here's the mind-blowing part: despite its staggering size, it's not even the most massive star we've found. Hypergiants like UY Scuti are so vast that they barely hold themselves together, with gravity struggling to contain their outer layers. These stars defy physics in ways that still baffle scientists. Their sheer size means they burn through their fuel at an astonishing rate, living fast and dying young in cosmic terms. While our sun will shine for billions of years, UY Scuti might only last a few million before exploding in a spectacular supernova. What's even crazier? Hypergiants like this are cosmic factories, forging heavy elements in their cores that will one day seed new stars and planets. So next time you look up at the night sky, remember, somewhere out there, a star like UY Scuti is stretching the very boundaries of what a star can be. Up next, we'll explore explosions so powerful they outshine entire galaxies. But now, let's turn our attention to something even more violent and spectacular: hypernovas. Imagine an explosion so powerful it makes a supernova look like a firecracker. These cosmic cataclysms are among the most energetic events in the universe, unleashing forces beyond comprehension. Hypernovas occur when massive stars, far heavier than our Sun, collapse under their own gravity. Unlike a typical supernova, which marks the death of a star, a hypernova is the result of a star so massive that its core doesn't just collapse, it implodes with such intensity that it triggers a gamma-ray burst. These bursts are the brightest electromagnetic events known, outshining entire galaxies for a few fleeting seconds. the energy released in a hypernova is staggering. In just a fraction of a second, it can emit more energy than our Sun will produce in its entire 10 billion-year lifetime. But the real magic happens in the aftermath. The extreme conditions inside a hypernova forge elements like gold, platinum, and uranium precious metals that eventually find their way into planets and even into the jewelry we wear. What's truly mind-bending is that these explosions are so rare, astronomers have only observed a handful, yet their impact is universal. Without hypernovas, the cosmos would lack the heavy elements needed to form rocky planets like Earth or life itself. So the next time you admire a gold ring or gaze at the stars, remember, you're witnessing the legacy of the universe's most extreme explosions. And speaking of extreme, wait until you hear about the bizarre phenomenon of cosmic recycling, where the universe turns stardust into something entirely new. Now, let's explore one of the universe's most fascinating processes, cosmic recycling. Picture this: every atom in your body, the air you breathe, even the device you're using right now, was once forged in the heart of a dying star. Supernova don't just end stars, they scatter the building blocks of life across the cosmos. When a massive star explodes, it blasts out elements like carbon, oxygen, and iron into space at incredible speeds. These elements mix with clouds of gas and dust, forming new stellar nurseries where the next generation of stars and planets will be born. Over billions of years, these recycled materials clump together, creating everything from rocky worlds to the very molecules that make life possible. But the journey doesn't stop there. Some of these elements become part of comets and asteroids, which later deliver them to planets like Earth. That's right, the water in your glass, the iron in your blood, and the calcium in your bones all traveled across the galaxy before becoming part of you. This endless cycle of destruction and creation means the universe is constantly reinventing itself. Without supernova scattering these essential ingredients, planets like ours wouldn't exist, and neither would we. So in a very real way, you're made of stardust, the remnants of cosmic explosions that happened long before our solar system even formed. And just when you think the universe couldn't get any more incredible, wait until you hear about the next extreme environment, where diamonds rain from the skies of distant worlds. Now, let's take a journey to the outer reaches of our solar system, where the weather isn't just extreme, it's downright otherworldly. Imagine a place where diamonds don't just sit in jewelry stores but literally fall from the sky. Welcome to Neptune and Uranus, the ice giants where the atmosphere cooks up one of the most bizarre weather phenomena in the universe, diamond rain. Deep within these planets, the conditions are so intense that methane, a simple molecule made of carbon and hydrogen, gets crushed under pressures hundreds of thousands of times greater than Earth's surface. This immense force breaks the methane apart, releasing carbon atoms. Those carbon atoms, now free, are squeezed even further, forcing them to crystallize into diamonds. Yes, actual diamonds, but here's where it gets even wilder. These diamonds don't just sit there, they're heavy, so they sink through the dense layers of the planet's atmospheres like glittering raindrops. Scientists believe these diamond showers could create vast oceans of liquid carbon deep inside Neptune and Uranus, with diamonds possibly piling up like hailstones near the cores. Think about that for a second. On Earth, diamonds are rare treasures, but on these distant worlds, they're as common as raindrops in a storm. It's a stunning reminder of how diverse and unpredictable the universe can be. And if you thought that was mind-blowing, just wait until we dive into the next extreme environment where the very fabric of space and time gets twisted beyond recognition. But before we dive into the mind-bending distortions of space and time, let's take a moment to listen to the universe in a way you've never heard before. Imagine a sound so deep and powerful that it bends the very fabric of reality, except here's the twist: space is a vacuum, so sound as we know it can't travel. Yet black holes somehow find a way to speak. scientists have discovered that the colossal gravitational pull of black holes creates ripples in space-time, pressure waves so intense they can be translated into sound. Using data from observatories like Chandra and LIGO, researchers convert these waves into frequencies our ears can detect. The result, a haunting, otherworldly hum, like the lowest note on a cosmic piano, vibrating for billions of years. One of the most famous examples comes from the Perseus galaxy cluster, where astronomers amplified the pressure waves around its central black hole, a staggering 57 octaves below middle C. It's a sound so deep it would take a piano with keys stretching over a mile long to play it. And while you'd never hear it in space, these sonic translations give us an eerie way to listen to the universe's most destructive forces. So next time you think of black holes as silent voids, remember, they're actually singing a bass note so low it shakes the cosmos. And if that sends chills down your spine, just wait until we explore how these monsters don't just warp sound, they warp time itself. Now, let's shift our gaze to one of the universe's most mesmerizing illusions, gravitational lensing, where the cosmos itself becomes a master of deception. Imagine light traveling across billions of light years, only to be twisted and warped by the sheer gravity of massive objects like galaxies or black holes. This isn't science fiction, it's a real phenomenon predicted by Einstein's theory of relativity, and it creates what we call cosmic mirages. When light passes near a massive object, its path bends, much like how a magnifying glass distorts an image. But in space, this distortion can produce stunning effects. One of the most breathtaking is the Einstein ring, where a distant galaxy's light is stretched into a perfect circle around a closer massive object. Hubble has captured countless examples of these celestial halos, each one a snapshot of gravity's invisible hand at work. Sometimes the effect is even more dramatic. A single distant galaxy can appear as multiple images scattered around the lensing object like pieces of a broken mirror. These cosmic doppelgangers aren't just visual curiosities, they're tools for astronomers. By studying these distorted images, scientists can map the distribution of dark matter, measure the universe's expansion, and even peer further back in time than telescopes alone would allow. Gravitational lensing is proof that the universe loves to play tricks on us, but in doing so, it reveals secrets about the very fabric of reality. And as we unravel these illusions, we're one step closer to understanding the grand cosmic puzzle. Next up, we'll witness the explosive collisions that forge the universe's most precious metals. Prepare for the dazzling spectacle of kilonovas. Now, let's turn our attention to one of the universe's most spectacular light shows, kilonovas, the cosmic fireworks that outshine entire galaxies. Picture two neutron stars, each more massive than our sun but only the size of a city, locked in a deadly dance. As they spiral closer, their immense gravity stretches and distorts them until, boom, they collide in an explosion so powerful it ripples through the fabric of space-time itself. This isn't just a dazzling display, it's a cosmic forge. The extreme conditions during a kilonova blast are so intense that they create elements like gold, platinum, and uranium. In fact, most of the gold in your jewelry likely came from a neutron star collision billions of years ago. These rare events are like the universe's alchemists, turning ordinary matter into precious metals through sheer force. Scientists first confirmed a kilonova in 2017, when gravitational waves from such a collision reached Earth. Telescopes around the world scrambled to capture the aftermath, revealing a glowing cloud of heavy elements expanding into space. This discovery solved a long-standing mystery where heavy elements in the universe come from, and proved that neutron star mergers are among the most productive factories in the cosmos. Kilonovas remind us that even destruction can be creative. These violent collisions don't just end lives, they seed the universe with the building blocks for new worlds. And as we continue to spot these cosmic fireworks, we uncover more clues about how everything from planets to people came to be. Up next, we'll race across the cosmos with stars moving at unimaginable speeds, hypervelocity stars that defy gravity's grip. Now let's shift gears to something truly mind-bending: stars that don't just drift through the cosmos but race across it at unimaginable speeds. Meet hypervelocity stars, the universe's ultimate speed demons. These aren't your average stars lazily orbiting a galaxy. They're cosmic projectiles hurtling through space at millions of miles per hour, fast enough to escape the Milky Way entirely. So, how does a star reach these extreme velocities? The answer lies in the gravitational chaos around supermassive black holes. Picture a binary star system, two stars orbiting each other, wandering too close to a black hole. The black hole's immense gravity captures one star, while the other gets flung outward like a slingshot, accelerated to speeds that defy the galaxy's pull. It's nature's version of a cosmic catapult, turning stars into interstellar fugitives. The first hypervelocity star was discovered in 2005, racing away from the Milky Way at over 1.5 million miles per hour. Since then, astronomers have spotted dozens more, each with its own unique trajectory. Some are even on a one-way trip out of the galaxy, destined to drift alone through the vast emptiness between galaxies. What's truly fascinating is what these stars reveal about the universe. By tracing their paths backward, scientists can map the hidden forces at work around black holes and even uncover clues about the Milky Way structure. Hypervelocity stars are more than just cosmic oddities. They're high-speed messengers carrying secrets of the universe's most extreme environments. Next up, we'll journey to the edge of time itself with a star so ancient, its existence seems to defy the very age of the universe. Now, let's turn our attention to a cosmic mystery that seems to defy logic, a star that appears older than the universe itself. Meet Methuselah, officially known as HD 140283, the oldest known star in the cosmos. With an estimated age of around 14.5 billion years, it poses a fascinating paradox, considering the universe is only about 13.8 billion years old. How can a star predate the very fabric of reality? Scientists measure Methuselah's age by analyzing its composition, particularly its low metal content. Stars born early in the universe's history formed from almost pure hydrogen and helium with very few heavier elements. By studying the star's spectrum, astronomers can estimate how long it's been burning. But here's where the puzzle deepens. Initial calculations suggested Methuselah was older than the universe, creating a head-scratching contradiction. The resolution lies in refining our measurements. Updated data, accounting for factors like the star's distance and helium content, adjusted its age to just slightly younger than the universe. Yet it remains tantalizingly close to that boundary, pushing our understanding of cosmic timelines. Methuselah serves as a cosmic time capsule, offering glimpses into the universe's earliest moments and challenging us to refine our models of stellar evolution. Next, we'll venture into the shadows of the cosmos, where primordial black holes lurk, remnants of the universe's violent birth. But before we dive into the shadows, let's unravel another enigma: primordial black holes, cosmic relics that might have formed in the universe's earliest moments. Unlike the black holes we know, born from collapsing stars, these mysterious objects could have emerged in the chaotic aftermath of the Big Bang itself. Picture a universe so dense and hot that random fluctuations in energy collapse directly into black holes, some as small as an atom yet packing the mass of a mountain. What makes primordial black holes so intriguing is their potential link to dark matter, the invisible glue holding galaxies together. While most dark matter is thought to be made of exotic particles, some scientists speculate these ancient black holes could account for at least part of it. Imagine countless tiny black holes drifting unseen through space, their gravity subtly shaping the cosmos. The hunt for evidence is ongoing. Some theories suggest these black holes could reveal themselves by distorting light from distant stars or even emitting faint Hawking radiation as they slowly evaporate. Though we've yet to confirm their existence, their discovery would rewrite our understanding of the universe's infancy. Now, let's turn our gaze to another cosmic tempest, Neptune's dark vortex, a storm so vast it could swallow Earth whole. Shifting our focus to the outer reaches of our solar system, we encounter Neptune's dark vortex, a monstrous storm swirling in the planet's frigid atmosphere. Unlike anything on Earth, this colossal tempest is a churning maelstrom of methane clouds, stretching wider than our entire planet. Imagine winds howling at over 1,000 miles per hour, whipping frozen gases into a frenzy so violent it could shred anything in its path. What makes this vortex even more fascinating is how it mirrors Jupiter's Great Red Spot, yet with a twist. While Jupiter's storm has raged for centuries, Neptune's dark vortices are more fleeting, appearing and vanishing within just a few years. Scientists believe these storms erupt from deep within the planet's icy layers, where pressure and temperature extremes create turbulent weather unlike anything we see elsewhere in the solar system. Voyager 2 gave us our first glimpse of this phenomenon back in 1989, capturing eerie images of the vortex as a shadowy blotch against Neptune's vibrant blue haze. Since then, telescopes like Hubble have tracked these storms, revealing how they drift and change over time. The dark vortex isn't just a storm, it's a window into the chaotic forces shaping Neptune's atmosphere, where even the most extreme weather patterns come and go like ghosts in the cosmic wind. Now, let's venture even deeper into the cosmos, where galactic winds sculpt entire galaxies with their unimaginable power. Leaving the storms of Neptune behind, we now turn our gaze to something far grander, the galactic winds roaring through starburst galaxies. These aren't just breezes on a cosmic scale, they're titanic rivers of charged particles screaming outward at millions of miles per hour with enough force to reshape entire galaxies. Picture a hurricane, but one that spans thousands of light years, blasting raw star-forming material into the void. These winds originate in galaxies undergoing explosive star birth, where countless new stars ignite in rapid succession. The combined energy of their radiation and supernova explosions hurls gas and dust outward, creating a feedback loop that can either fuel further star formation or choke it off entirely. It's a cosmic tug-of-war one that determines whether a galaxy blazes with young stars or fades into quiet middle age. What's truly staggering is the scale of their influence. Galactic winds don't just alter their home galaxies, they spill into intergalactic space, seeding the cosmos with heavy elements forged in stellar furnaces. Without these winds, the universe would lack the building blocks for planets or even life itself. Telescopes like the Hubble and ALMA have traced these outflows, revealing intricate webs of matter stretched across the darkness like fingerprints of creation. So the next time you gaze at the night sky, remember, even the emptiest voids between galaxies are alive with invisible rivers, sculpted by winds too vast to comprehend. And speaking of vastness, let's push further into the unknown, where ice takes on forms stranger than fiction. But now, let's plunge into the depths of alien oceans where ice defies everything we know. Imagine water so densely packed that it forms a crystal harder than steel. This is Ice 7, a super dense form of ice found in the crushing depths of exoplanet oceans. Unlike the fluffy snowflakes on Earth, Ice 7 is born under pressures hundreds of thousands of times stronger than our atmosphere, with molecules squeezed into a grid so tight it could slice through ordinary ice like a knife. What makes this cosmic ice truly bizarre is how it behaves. On Earth, ice floats because it's less dense than liquid water. But Ice 7 sinks. Its structure is heavier than the water around it, turning our everyday physics upside down. Scientists believe entire layers of exoplanet oceans could be made of this sinking ice, creating underwater glaciers that creep along the seafloor. Some exoplanets might even have hot ice, where temperatures soar to hundreds of degrees, yet the pressure keeps the water locked in solid form. The secret lies in its molecular handshake. Under extreme pressure, water molecules bond in a symmetrical cubic pattern, far more orderly than the chaotic arrangements in Earth's ice. Space telescopes have spotted hints of these exotic oceans on worlds like Gliese 436b, where the surface is scorching hot, but unimaginable pressures below preserve Ice 7 in perpetual defiance. So while we're used to ice that melts and freezes, the universe cooks up varieties that would leave even a chemist stunned. And if you think that's extreme, just wait until we venture into the fiery cradles where stars are born. Now, let's turn our gaze to the cosmic forges where stars are born, protostars, the blazing embryos of future suns. These celestial fireballs are where the universe's most extreme fires rage as gravity and heat collide to spark the birth of a star. Picture a swirling cloud of gas and dust collapsing under its own weight until the core becomes so dense and hot that nuclear fusion ignites. This is the moment a protostar awakens, burning at temperatures reaching millions of degrees. What makes protostars so fascinating is their violent infancy. They're not just hot, they're chaotic, spewing jets of material light years into space as they devour surrounding gas. These fiery nurseries, often hidden within dense nebulae, glow brightest in infrared light, revealing their secrets to telescopes like the James Webb. In places like the Orion Nebula, hundreds of protostars flicker to life, each one a potential twin to our own sun in the making. The process is a delicate balance. Too much mass and the protostar might explode or collapse into a black hole. Too little and it fizzles out as a dim brown dwarf. But when conditions are just right, the fusion reactions stabilize and a new star joins the cosmic tapestry. These stellar birthplaces are more than just spectacular, they're the factories that forge the elements essential for planets, and even life itself. So while protostars may be hidden behind veils of dust, their extreme fires light up the universe in ways we're only beginning to understand. And speaking of cosmic extremes, our next stop takes us to the eerie silence of the universe's oldest echo. But before we leave the roaring fires of protostars behind, let's step into the quietest corner of the cosmos, the cosmic microwave background. This faint afterglow is the universe's oldest whisper, a relic from when everything began. Imagine turning down the volume of the entire cosmos to near silence, and what remains is this faint glow, barely warmer than absolute zero. This cosmic microwave background is like a snapshot of the universe when it was just 380,000 years old, a time when atoms first formed and light could finally travel freely. What makes it extraordinary is that it's not just random noise. It's a precise map of the early universe's structure. Tiny fluctuations in this radiation reveal where matter first clumped together, sowing the seeds for galaxies and galaxy clusters we see today. Scientists study this ancient light like detectives deciphering a cosmic fingerprint. The patterns in the glow tell us how fast the universe is expanding, how much dark matter exists, and even hint at the mysterious force of dark energy. It's as if the Big Bang left behind a message in the sky, written in microwaves, waiting for us to decode. So while the cosmic microwave background might seem like the universe's quietest hum, it speaks volumes about our origins. And as we unravel its secrets, we're listening to the echoes of creation itself. Next, we'll venture into the shadows where unseen worlds drift through the void, rogue planets, the universe's ultimate nomads. Now, let's turn our attention to the cosmic shadows where some of the universe's most mysterious wanderers drift, unseen rogue planets. These lonely worlds don't orbit any star. Instead, they roam the darkness of interstellar space, untethered and invisible to the naked eye. Picture a planet like Earth, but cast adrift in the void, where the only light comes from distant stars or the faint glow of its own volcanic activity. Rogue planets likely form in one of two ways. Some are born in the chaos of a young star system, only to be flung into the abyss by gravitational tugs from neighboring planets or passing stars. Others may form on their own, collapsing directly from clouds of gas and dust too small to ignite into stars. Without a sun to warm them, these worlds become frozen wastelands, their surfaces plunged into perpetual cold. But here's the twist: some might not be as lifeless as they seem. Deep beneath their icy crusts, tidal forces or radioactive decay could generate enough heat to sustain hidden oceans, much like Jupiter's moon Europa. If liquid water exists, could life cling to existence in these sunless realms? Scientists speculate that microbial life might thrive near hydrothermal vents, drawing energy from chemical reactions rather than sunlight. It's a haunting thought: entire ecosystems lurking in the dark, completely cut off from the rest of the universe. Artists' renditions of rogue planets often show them as frozen orbs, bathed in eerie auroras or shrouded in methane haze. But the truth is, we know very little about them. They're nearly impossible to detect unless they pass in front of a distant star, bending its light ever so slightly. Each discovery peels back another layer of mystery, hinting at a galactic population of these nomads that might outnumber the stars themselves. As we ponder these shadowy wanderers, we're left with a profound question: what other secrets hide in the darkness between the stars? Next, we'll confront the universe's greatest unsolved puzzle, a force so mysterious it defies everything we think we know: dark energy. Now we arrive at the grand finale of our cosmic journey, the most baffling mystery of them all. Dark energy isn't just an enigma, it's the invisible hand reshaping the very fabric of the universe. Imagine a force so powerful it's pushing galaxies apart at an ever-increasing speed, yet we can't see it, touch it, or even fully comprehend it. This is the puzzle that keeps cosmologists awake at night. Here's what we do know. In the late 1990s, astronomers made a shocking discovery. The universe isn't just expanding, it's accelerating. Something was counteracting gravity's pull, and they called it dark energy. Think of it like this: if the universe were a loaf of bread baking in an oven, dark energy would be the yeast making it rise faster and faster with no end in sight. But what is it? The leading theory suggests dark energy might be a property of space itself, a cosmic constant woven into the vacuum. Empty space isn't truly empty. It's seething with quantum fluctuations that could be driving this expansion. Another idea: dark energy might be a new, undiscovered force field, something beyond the known laws of physics. The strangest part: dark energy makes up about 68% of the universe's total energy, yet we've never directly detected it. It doesn't interact with light or matter. It just is, and if it keeps accelerating the universe's expansion, billions of years from now, distant galaxies could vanish from view entirely, leaving future civilizations with a night sky nearly empty of stars. This isn't just a scientific challenge, it's a philosophical one. Dark energy forces us to confront how little we truly understand about reality. Will we ever solve it? Perhaps, but for now, it remains the ultimate cosmic mystery, a reminder that the universe still holds secrets beyond our wildest imagination. And with that, we've reached the end of our exploration of the universe's most extreme environments. From scorching galaxy clusters to rogue planets, from crushing neutron stars to the unfathomable force of dark energy, we've witnessed the cosmos in all its terrifying and awe-inspiring glory. If this journey through the extremes of space left you as amazed as it did me, don't forget to hit like, subscribe, and ring that notification bell so you never miss our next cosmic adventure. Until then, keep looking up. The universe has so much more to reveal. What an incredible journey it's been. From the blistering heat of the Phoenix cluster to the eerie silence of the Boötes void, we've explored 50 of the universe's most extreme environments, each one stretching our understanding of reality to its limits. These cosmic wonders remind us just how strange, vast, and unpredictable the universe truly is. Whether it's the crushing gravity of a black hole, the diamond rain on Neptune, or the mind-bending mystery of dark energy, every fact we've uncovered reveals a universe far wilder than we could have imagined. So, which extreme environment left you the most awestruck? Was it the supermassive black holes, the rogue planets drifting through the void, or something else entirely? Let us know in the comments below. We'd love to hear which cosmic wonder blew your mind the most. And if you've enjoyed this voyage through the universe's most extreme corners, don't forget to hit that like button, subscribe, and turn on notifications so you never miss our next deep dive into the cosmos. The universe is full of mysteries waiting to be uncovered, and we're just getting started. Until next time, keep exploring, stay curious, and remember, the greatest adventures are written in the